Today I'm going to show you in Autodesk Fusion how you can create joints to be able to make assemblies that can move and make more efficient assemblies when you're making your designs. With the goal of being able to make something like this, where you could take a simple arm and now you can rotate it around and you can see that all these different components work together depending on what joint it is that you are grabbing. Oh, and I'm Brogan Pratt. I've been teaching robotics and design for over a decade now. And this is more or less what I do on a day-to-day basis, is teaching students how to be able to build robots and design things like that. So let's talk about the plan for today. We're going to start off talking about components versus bodies and the importance of when you need to use each one inside of your assemblies. We'll talk about grounded components and what that actually means and how that works for your assemblies. We'll talk about joint origins, different ways you can move things together, and then lots of different joint types that you have access to inside of Fusion. We'll also talk about a couple different methods for how you might be able to make joints to be able to make sure that things meet together. And then we'll talk about the hybrid model design flow so that you can actually design something like this by the time you're actually done. And this comes with things like also working with importing external components that you've made or components you found online for your own assemblies. And then we'll also talk about how you can test and refine some of those components and how they are interacting with one another. So the goal for today is to be able to make something along these lines, and how these components are interacting together are working with things called joints inside of Fusion. So if we're looking at our design here, we can see that there's a couple different joints that already exist inside of our design. Inside of our browser panel, we have a metal piece here that holds the whole frame together. We have a motor that's able to rotate things around. We have a hub-based element here that is able to clamp our first bar of that linkage as then connect to that second bar of that linkage. Now we have things like this motor here. We can't drag and move it around because it is rigidly attached to this main motion here. So if I were to try to drag and move this thing around, it's not able to move. Now, these components here are connected with something called a revolute joint or a rotational joint. And we can see that when we look at our position here, we can see our angle for our revolute joint. And as we rotate this around, we can see that little angle number changes as we rotate around that joint. The same is true with our other revolute joint here, where we can click and drag this around and we can see again that angle changes depending on how those two are connected together. Now, because I have two revolute joints and we move this together, we can actually see, and Fusion will model for us, how these two objects are going to connect together if I were to keep these things inside of this main plane. You'll also notice as I rotate this around that this sonic hub right here in the middle also stays and rotates as I rotate that top joint. So let's talk about how we actually move this. The first thing to know about working with joints and components as you start to make larger assemblies is that you always have to have some sort of component that is grounded. You'll notice that there's this little anchor symbol next to this U-channel piece. And this piece of metal, which is our U or C channel, is grounded, which means that if I were to click my little home here, there is one piece that will never move, and that is the parent object, so to speak. So we will never be able to move that object around, and everything is going to rotate and move relative to that grounded object that will never actually move. So you always have to have something grounded inside of your object or your assembly. The next thing to know about this is that all of your objects also need to be components. You cannot add joints to simple bodies. So we have to make sure we're adding those as components instead. So let's actually go ahead and start making some of these. If you want all these files for these individual step files down there, I'll link them in a file in the description down below so that you can build along with me here too. So I'm going to start by making a new design, and we're going to make a hybrid design because in this case, we are not making an individual part. We're not assembling pre-built parts. We're also going to be building some of these. And this is kind of classic Fusion design as well. We'll go ahead and save this first. We'll call this one a simple robot linkage. And I'm going to write a tutorial in this as well, just to make sure we got some good practice. Now, the first thing we're going to do is we're going to add in that solid piece of U-channel, and we're going to ground that inside. So I have it inside of my panel here. I'm going to search for U-channel. You, of course, can simply do File and then select Open, and then save your file as a separate file here, and it will show up inside of one of those sections. Then we can right click and select Insert into Current Design. That will take one of those external components or previous components that we've made, and it will insert it into our object here. You're welcome to go ahead and move this around as you'd like to be able to get it inside of your current position. There are 3 slider bars here for the Y-axis, the Z-axis, and the X-axis, and you're welcome to move this as you see fit. I like to line my first component up on the origin point here so that I have that central point moving forward. The closer you zoom in, the smaller increments you'll be able to move your objects in, and the further out you zoom, the larger the increments are going to be that you're moving your object in. Once you're happy with this, in our initial position, we can also simply ground this to the parent, but I'm going to not select that box for now. I'd suggest that you do, but on the off chance that you don't end up grounding this parent, and you're now able to move this thing around, instead what you can do now is you can select your object, select whatever face it is that you wanted to, and then right click on the object and say ground to parent, and that will hold it inside of that specific position that you want. And now if I try to click and drag this around, you'll notice that I cannot move or manipulate this object anymore, which is what we want. So this is our base reference point for our design. It's up to you to decide what you want your base reference to be. Now inside of this piece of channel here, we're also going to add in a motor. So I'm going to search for my rev motor, because this is what you guys have put in my files down below. And I'm going to grab this one here, and I'll right click and insert into the current design. Again, if you haven't uploaded that folder, make sure you do that file upload to the folder. And for this one, we can just move it clear and out of the way for now. And we're going to make sure we do not select ground to parent, because otherwise what's going to happen is it will ground it inside of this position. Now, before we start moving a very large object like this object has a whole lot of pieces in it. And for our example in this design, none of the pieces on this motor here are actually going to move. So before I move this in, I'm going to select right click, and I'm going to select rigid group. Now what a rigid group does is it locks all of those joints and all those individual pieces inside of that component together so that they don't move around. What ends up happening is, and it's going to constrain select components, this is okay, select yes, and then select all right. So now this entire component now acts as an individual object. If you did not make it a rigid group and you were to start adding in joints and relative geometry to these things, what's going to happen is that you're going to move individual pieces from that. So for example, you might grab just this drive shaft, or you might grab just this cap, and you'll end up blowing apart your component, which is not what we want. Now let's get into joining these two pieces together. So we want some way of relatively moving these things together at the same time. And we're going to do that with a simple joint. So if I select Assemble and I select Joint, you can also press J on your keyboard to open that up. Now we can actually start finding ways to join things together. And we can join things on faces, we can join things on points, we can join things on edges. We can also join things on snap geometries, and we'll talk about all of those. So let's say, for example, I wanted to join this face here onto another face. So I'm just going to select this face, and we can see that there's this little snap point origin that's popping up, because Fusion is smart enough to know that, hey, you probably want some sort of reference point on your geometry for where you want to actually do that joint. So I'm going to select this top left-hand corner. It's going to keep it in this orientation. And then I can move over and select a different position that I want it to snap to. And we can see that right now, mine is currently doing a revolute joint. So I'm going to swap this back to rigid. Yours is likely going to be rigid at the start. We'll talk about that in a second. So now as I move this in, we can see that I can actually rotate and move this joint around as it is that I want to. You can also have joints move in different positions. Now, in this case, I actually don't want to snap those two together, so I'm going to remove both of those because there's an easier way for me to joint these two together. I'm going to select one of these holes here because these are lined up with my pattern. And if I select the edge of this ring here, or this circle, what ends up happening is you can see that rather than grabbing one of these threads, and I can move it over, and we actually see that snap origin point goes into the center of that hole, which is what I want. I like to work center to center. It makes life a lot easier. Now if I come over here, I change my view angle, and I select, again, the center of this hole here by grabbing this edge. You may need to move your mouse around, or you can click and hold, and you can select different sections until you have the point that you would like to select to. And this is, I'm pretty happy with where this is actually going to go. You'll notice that it's only going to move that individual component for now, and that's okay. The whole rigid group is going to come on with it later. Now when it comes to the motion, I'm going to select motion, I'm going to select rigid. Now rigid is they're going to lock the two components together because those are never actually going to move, because we're going to add some fasteners in here later. They're never going to move. You can click this little preview and it will show you that, hey, those two objects, if you were to shake and vibrate them all around, they're never going to move. We don't have to worry about any of this alignment stuff. We can go ahead and flip this so it goes on the other side, but we've selected the correct object, and we can see that once we select OK, the rest of the object moves along with it. Now, the next part we're going to add is we're going to add in a rotating hub to the end of this. So I'm going to search for my sonic hub here. And I'm going to insert this into my current design as well. Again, feel free to move this wherever it is that you want it to once you actually insert it into the design. It doesn't matter. I like to just move it out of the way for now. Make sure I have ground apparent deselected. And I'm going to make sure that I have right click, and I'm going to set this as a rigid group, because otherwise what can happen is I will move those individual components because this has multiple bolts inside of it. We don't want these moving outside. Now again, we're going to grab a joint. So I'm going to select J on my keyboard to open up a joint. And I'm going to grab this edge here on the outside of this circle so that I can grab to that center snap point that's in the center of that ring. Select that. We'll come over here to the edge of our motor shaft, and I'm going to select this axle over here. And again, you can move it or you can click and hold until you can select the edge that you actually want to center on. I like the center of this edge. And now for this component, we are not going to make it a rigid component. Instead, I'm going to select motion, and I'm going to select revolute. And this allows it to rotate around in a full 360 degrees. You can also select preview. Now, there are also joint motion limits. If you want to get fancy into this, you can say that, hey, you want it to have a minimum of 90 degrees. So when you try to rotate this around, you'll notice that it won't actually rotate beyond specific sections anymore. So you can rotate it, say, between 90 and 180 degrees, and now the rotation will only move between 90 and 180. It's no longer capable of moving all the way around. But in our case, because this is a simple motor, it's going to move all the way around. You can also have it rest at a specific position, at which point you can say where you would like this object to rest. So if you want to rest at 170 degrees, it will stay there when it is in a resting position. And you can give it a preview, and that's where its start and stop positions are going to be. I'll stop that and I'll select OK on that preview. Now, up to this point, if I were to click and drag things around, I can now click and drag and rotate around this revolute joint. And when I let go, it automatically snaps itself back to the rest because I added that rest position. I'm going to go ahead and modify that relationship. If I come down to this browser underneath relationships and joints, you'll notice that I have several different joints in here. Before I get too far, I'm going to go ahead and rename these. So this rigid, I'm going to rename. And I always like to rename the object that is being jointed to whatever its first parent is. So in this case, it is the motor to the U channel. And this revolute joint here, I'm going to rename this, and I might give it a R, or actually we don't even need to get revolute because it has it on there. This is the sonic to the motor, or the hub to the motor. And this is just good practice. If I were to open this up, I can now edit this rotate if I wanted to. So I can either lock this so it doesn't move, or I can click this little arrow to be able to edit those motions. I'm going to remove that rest so that it stays at that current position. So we'll modify that. So now I'm actually going to go back and put that rest back on because we're about to make that first linkage and we want to have some reference points from this geometry. So I'm going to go ahead and edit this ramp here. We'll change our rest, and I'm going to rotate this rest up just so we are about in that kind of 90-degree orientation. And then after setting it up, we'll pull it up to its resting position here. And then we will just capture that position so that we can do an easier sketch. So now we're going to make that linkage. So let's right click and make a new component. We're going to call this component linkage 1. And then we're going to make a new sketch on the face of this mounting hub we did. So we can click and hold until we select the face that it is that we actually do want to draw our sketch on top of. And then we're going to make a couple quick projection lines just so we can know where our holes need to be. So I'll press P on my keyboard to project. I'll project this face. I'll project this face. And then I'll also project the hexagon input of our motor as well. So we'll select OK. And now, so that we don't have such a busy workplace, we can right-click on our linkage, select Isolate, and it will just hide everything else for now, so we don't have such a visually busy piece. We'll now grab a rectangle, and we're just going to simply click and drag to make something large with no reference geometry. We don't worry about where anything is right now. We'll use a couple tangent constraints just to hold everything in, or honestly, we can just leave this overly large, and that's also totally okay at this point because we're not doing a full sketch here. We'll make a circle. Imagine we have some sort of ball bearing or some sort of constraining place for that circle to then pull itself on, and we'll go ahead and finish this sketch. Decided here, we can go ahead and select Extrude, and we will grab all the faces that we'd like to extrude, and we'll extrude out 4 millimeters. At this point, we can go ahead and unisolate this. And we've now seeing everything back. And now to be able to mate these two components together, both that hub and that main face, we have to go ahead and make our main assembly our active component or the parent component of what components we're actually working on in this case. So now I can select Assemble, and instead of selecting Joint, we're actually going to do an As-Built joint. The difference between an as-built joint and a standard joint is that with those joints, we are mating the two pieces together. But with an as-built joint, we're taking them as they are built or assembled in place. So we can go ahead and select these two, and this is going to be a rigid component. And now we'll see that as we click and rotate these around, that both components move together. So we can see that both that hub is now rotating and that main piece is now rotating. So we'll go ahead and make one more component here. We're going to call this one linkage number 2. We'll make a new sketch on top of the main face. And again, we're not super concerned about making this a really fancy sketch or anything. So I'm just going to add in another large bar and we'll finish our sketch. We can select Extrude or pressing E or Q on our keyboard. We'll extrude these both out and we'll make it 4 millimeters. Now, in order for these two to come back together, you can probably guess we're going to make our main component the active component again. And then we're going to assemble and select an as-built joint. We'll select our two joints, but this time, instead of rigid, we're going to select revolute. And the revolute also expects where that snap is going to be. So we zoom in here, and that snap is basically where are these two components going to be rotating relatively to each other. So I'm going to make this center as my revolution point. I'll make it a full 360 because we aren't going to constrain these for where they're going to be. We'll select OK. And now as we click and rotate, we can move these individual joints and we can move both joints at the same time. Now you'll notice as I rotate this joint around, this other joint is not moving. It's because it's currently at rest. So if I were to remove that rest from that other joint, we can now have both of them moving together independently. So I hope that you find that that helps speed up some of your Fusion designs with moving components around, marrying components around together, as well as starting to get in the capacity for some things like some motion studies. If you got any more questions, let me know in the comments down below. And as always, best of luck on your next robotics project.